is the answer. Now why is that? So if the frequency, so there's period. We talk about what period is. Period is point to point, and then frequency is 1 over the period. So in some ways it's related to the period. So this has to somehow change when it goes through a different medium, like maybe it shrinks or gets give me just a moment, please. Be right back with you. Okay, so the frequency changes, and as a result, the period changes as well. Then that's just a pure definition for this. So,
okay.
All right. Okay, and then this. Okay, so the next question here talks about what the angle of refraction will be, whether it'll be greater than or less than. And an example would help, but I don't have a good one. Basically, it's like going from air to water would maybe be the most common example, air to water. And what happens, does the angle, see this angle right here, angle 1, and this angle 2. Angle 2 is greater than angle 1, but that's that I got to know if that's the more dense, if that's more dense or not. So let me just do another search on this one. This is this is covered in what's called thermodynamics as well. It's another part of physics. There's mechanics, which is probably what you did last semester, and then there's electricity and magnetism, and then there's this lights, thermodynamics and light thing.
Mm-hmm.
Oh boy. Less dense to more dense. Okay, so as it's more, this is probably an easier example to understand. Let me draw this one down here. So less dense down here to more dense. So less to more dense, which is what we're asking about here. See how the angle actually gets smaller.
Mm-hmm.
So I guess it's smaller than is how I would answer it there. Okay, and then the third question here, this when a ray of light, apparently this was an error. So there's two lines here. There's the, and this was apparently wrong. This one here, there's two lines. There is this normal to the surface. So there's the surface, and then there's the normal to the surface. And I guess because I didn't look at a textbook, the angle is made with respect to the normal here. So it's actually this angle. I've drawn it wrong a few times here. So it's actually this perpendicular to the surface.
Okay.
And that's probably in a picture. But this is the correct picture. I think I've been drawing it like in the previous examples. I've been drawing them here. That's actually not quite correct. It's actually this other angle.
Okay.
All right, so let's go back to some other questions here. I feel like we did 4 before. Maybe the let's see here. Okay, so the reflection is when it bounces back. So it bounces off a barrier is a reflection.
Okay.
Diffraction is the one that we're talking about a lot here. That's the one where it passes from one medium to another medium to another. That's diffraction. And then refraction, probably the best words to look at is the one that says around a barrier.
Okay.
Those are just definitions. These sketches show 2 waves about to meet the correct outcome. Okay. Let's do these one at a time. All right, so the letter A here, the waves are moving towards each other. And what they're trying to show you is that at some point they add together because they're both positive.
Mhm.
And if you've ever been on a trampoline, it's kind of when you get that double bounce from someone. I don't know if you've done that before, or if you play a musical instrument, I think the if you're in the right way of doing it, you can combine with each other. So right here in the middle, that's the red one, and then the blue one is right on top of it. So the net is something that looks like this right here, where they combine together.
Mhm.
So I don't know what the drop downs are, but something like that doubles the amplitude, some sort of doubling. Is that an option?
It's smaller wave, no change, or larger wave.
Larger wave. So the wave got larger
Okay.
because the wave is now up here. And then when they pass by each other, they both go back to the same. So they like when they pass each other, so the blue is going left. So later on, the blue is over here, and then the red is there on the right, and they just go by each
Mhm.
other. But for that moment where they're completely overlapping. So here with B in the middle, you have the red one up and the blue one down, and they end up canceling because
Mhm.
think of it as like +1, -1, +0.5, -0.5, and so on. And so there is no wave because it's completely canceled out.
Okay.
And so your noise canceling headphones, that's what they do. They actually, there's the misconception that they block the sound. That what they do is they actually create waves, so to speak, that cancel out with the ones that you're hearing,
Oh, okay.
which is, it's an odd thing to think about, but that is what's happening.
Okay.
Okay. Here's the next one that I see. Let me grab this. Okay, the phenomenon which occurs when two waves meet while traveling along the same medium. That's what we just were looking at. And the thing is that they could interfere, they could be disruptive. I want to say it's wave blend, but let me just double check. This is just another pure definition. Blending meaning that they somehow combined to I'm also seeing the word interference being used. Do you see anything in your notes that might help here?
Let me check.
Yeah, it looks like it's winter. It's so the literal words don't actually work here. The interference is the textbook one. That's what I'm seeing from a physics classroom resource. And there's two types. I guess there's construct. That's what I was looking for. There's constructive and then destructive, or those are the two types. So the constructive is when they are positive, adding together, and the destructive is when they're negative or they canceling, I believe.
Okay.
As an aside there. Huh. Okay, there's this picture in this next problem. It says the waves passing through a gap in the barrier, which describes what's happening. So I guess it's going this direction. But what's odd is you can see them here, but then there's this like overlap. Maybe there's another gap over here. So the four possible answers here are reflection, diffraction, refraction, and interference. And I think we looked at one where it like bends. We looked at that. Let me go back up here. See how we talked about diffraction being around a barrier?
Yeah.
So I would say this is a barrier. I mean, it even says that in the words there. So I guess if I had to put an answer down, I would go with diffraction because of that.
Okay.
All right. So I definitely know we did this problem previously. Is it here because it was marked wrong, or would it have shown as being marked wrong if there was an issue?
I
Because
don't
like
remember.
in some of the ones, it definitely, you know, it's you're showing me, hey, there was an issue here with this one. Because the way we did it is we said more loops, more voltage. So here there's 54 loops and 9 volts, but then it's going down to 45 loops and then X volts here. So you can make an equation, but you're trying to figure out how do you go from 54 to 45. And I think it's easier to actually, since you're going smaller, is to do that. 45 divided by 54. And then you end up multiplying that by 9 because that's like the multiplier on 9. And that will equal 7.5 volts. And I know we did one like this. So I'm going to assume that's okay. Okay, this one was the issue with this one. This is wrong. Is that there? We didn't really know what PD referred to.
Mhm.
I thought it was potential difference, and so there's the coil 1, coil 2, and I guess we can say it's induced in the core because the core is between them rather than the primary coil and the secondary coil. The
Mhm.
core is probably what it means by where it's induced.
Okay.
All right, so new problem here. So that's saying which leads to the greatest refraction of a light wave. So air to air. So air to air, there would be no refraction.
Mhm.
And so obviously it's one of these other ones here. So there's something, I think there's something like one of these is really well known to be the answer. And I want to say, well, I don't want to make a judgment, but like diamonds are used in, diamonds are more than just something you wear around. They're used in drilling and other things because they can harness the light waves that are
Mhm.
shown through them. But I don't know, so I'm just going to look. I guess I would tell you to go, if you've got options, this one would be first because it's such a it's the harnessing power of light, um, and it also speeds it up the most. So I probably would go with that one because of what I mentioned before about drilling and things like that.
Okay.
This next one here looks like another pure definition thing. So I'll have to look this up again. It says light will both reflect and refract. So here's, reflecting and refracting, going through the medium as well as coming back when the angle of incidence is, and yeah, what's one of these? I don't know. Let me do a quick look here. Um, believe it's the critical angle. That's probably why it's called a critical angle. There's total internal reflection or resonate. I'm not sure. I guess I would go with this one as my first guess. I can't seem to find anything but I'm sure this is something that might have been covered in notes or lecture things. So that is everything that I see that you sent. What do you want to do here with the rest of the time? What else do you have for us to look at today?
That's really all I have for us to look at today.
Okay. Well, I hope that helps. Maybe check your notes and lecture recordings if you got them one more time. Sometimes seeing it a second time will help. And we've got a lesson tomorrow for SAT prep, so I'll see you then.
Okay, thank you so much.
You're welcome. Bye now, Julia.
Bye.